This is the second block of Topic 6. In this lesson, we're going to be able to prove lines are parallel using special angles that we reviewed in yesterday's lesson. So three of the theorems that you learned yesterday had to do with parallel lines being cut by a transversal. Remember, a transversal is just a line that intersects two or more lines. So when you have parallel lines, those are two lines, and so when you have a line intersecting them, we call that line a transversal. So if you have parallel lines cut by a transversal, then we learned these three relationships. The alternate interior angles are congruent, the alternate exterior angles are congruent, and the consecutive, which means same side, interior angles are supplementary. So we're first going to look at this drawing here, and you can see angles 2 and 6 are a different color than the rest for a reason. And they're telling us here that the measures of angle 2 and 6 are both 55 degrees. Now, we reviewed yesterday that these pair of angles have a name. They're called corresponding angles, and it's because they are in the same position in relation to the transversal. They're both on the right side of the transversal, and they're in the same position in relation to these parallel lines. They are both above one of the lines. So since they are in the same relation to both of those things, they're called corresponding angles. So yesterday we wrote a theorem called the corresponding angles theorem, and it states if two parallel lines are cut by a transversal, then the corresponding angles are congruent. Now remember, if you don't have parallel lines, you still have corresponding angles. It's just they don't have the relationship of being congruent if the lines are not parallel. So in question 1 of your notes, we're going to write the converse of this statement. Remember, the converse is switching the hypothesis and the conclusion, but it's not just as easy as saying if corresponding angles are congruent, then two parallel lines are cut by a transversal. That doesn't make sense, okay? So the way that we would write the converse of this theorem is if you have two lines cut by a transversal so that the corresponding angles are congruent. That has to be the given part. You have to have two lines cut by a transversal with corresponding angles are congruent. The conclusion, the then part of your statement will be that the lines have to be parallel as a result of that relationship. Okay, so again, that's question 1 in your notes. If two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So if we look at this animation here, right now it's very clear to see that these lines are not parallel. If they extended forever, they would eventually intersect. And you can see right now the angles 2 and 6, which are corresponding angles, are not congruent to each other. They do not have equal measures. So as soon as I move point P and make angle 2 congruent to, if I can do it, and make it congruent, good night, I can't get it there. Oh, there we go. And make the measure of angle 2 and the measure of angle 6 both 55 degrees. Now the corresponding angles are congruent, and voila, our lines are parallel as a result. So that illustrates the converse of the corresponding angle theorem. So if the corresponding angles are congruent, then yes, the lines have to have been parallel. So we have the original corresponding angles theorem that says you start off with parallel lines cut by a transversal, and your result is that the corresponding angles are congruent. And the converse is also true, that if you have two lines that are cut by a transversal and your corresponding angles are congruent as a given, then the result is the lines are parallel. So both ways are true. And remember, we could write this as a single statement, which we call a biconditional. We could join the hypothesis and conclusion with the phrase if and only if. All right, so we're going to look at our conjecture at this point, which will become a theorem after we prove it, that has to do with alternate interior angles. So remember, we reviewed yesterday that if these lines are parallel, then the angles that are on opposite sides of the transversal, but inside the two parallel lines, such as 3 and 6, are called alternate interior angles, and they have to be congruent. So in this proof, it's a 2-column proof. we are given that J is parallel to K. So we are given the hypothesis part of our conjecture. So remember, this is a very easy reason here. That is simply the given statement. Another easy, and this is, by the way, number 3 in your notes, so you can be following along as we go through this. And the other part that is really easy about the proof is, remember, the end statement better be what you're trying to prove. So we're trying to prove that if the lines are parallel, the alternate interior angles, angles 3 and 6, are congruent to each other. And so angles 3 and 6 being congruent is my final statement. So I just have 3 more blanks here to fill in. Number 2, the second statement in the proof, is using the vertical angles theorem, saying vertical angles are congruent. So remember, vertical angles are the non-adjacent angles formed when lines intersect. So like angles 1 and 4 are vertical, 2 and 3 are vertical, 5 and 8 are vertical, 6 and 7 are vertical. So when we look at over here at the choices, the one that we need to pick for this proof is angles 3 and 2. They are the non-adjacent angles formed by those intersecting lines J and T. Now, the next statement, remember, we should be able to tell the difference between statements and reasons over here as choices. We've already used angles 3 and 6 being congruent as our final statement, and we've already used angles 3 and 2 being congruent for vertical angles. So our only choice is to use angles 2 and 6 being congruent on number 3. And so the blank says, if parallel lines are cut by a transversal, then we know these angles are congruent. But we have to know what we call those angles. So when we look up here at the picture, angles 2 and 6 are what we started talking about at the beginning of the lesson. They're on the same side of the transversal, and they're both above the parallel line. They are called corresponding angles. So we're using the corresponding angle theorem in number 3 to help us prove the alternate interior angle theorem. And so here is our completed proof. We started with parallel lines. We used the vertical angles 2 and 3 being congruent, and we used the angles 2 and 6, corresponding angles being congruent, and then we used the transitive property. And that's because both angles 3 and angle 6 were both congruent to angle 2. So since they were both congruent to angle 2, we knew they had to be congruent to each other using the transitive property. So now we know this is called the alternate interior angles theorem. So now that we have proven that conjecture, remember it's called a theorem, so we just proved what's called the alternate interior angles theorem. Remember, both the theorem and its converse are both true. We could write that as a biconditional statement if we so wanted to. So let's look at our next proof. We're going to look at alternate exterior angles. So 3 and 6 were alternate interior because they were inside the parallel lines but on opposite sides of the transversal. Now we're looking at 2 and 7. They're still on opposite sides of the transversal. 7's on the left, 2's on the right, but now they're outside the parallel lines. So J is above, 2 is above line J and 7 is below line K. So they're outside the parallel lines. So our given is that we have parallel lines, and we're trying to prove that the alternate exterior angles 2 and 7 are congruent. So let me try to get this to where it all fits on one page. So remember, this is called a flowchart proof for obvious reasons, but still, just like with the 2-column, you still have to give statements and reasons in every single block. So they took one of the easy parts away from us, the fact that the given statement and the reason are both given in that first block. The other easy part, remember, is the statement on the last block here has to be what we're trying to prove. So we know angle 2 being congruent to angle 7, which are the alternate exterior angles, has to be down here. Now remember, your reason will never be the word prove. That's why you've never seen it as an answer choice, because it never makes sense to use prove as a reason. There has to be some other reason that allows you to get down here. All right, so if we look at the second box, the statement says if parallel line, not the statement, but the reason says if parallel lines are cut by a transversal, then corresponding angles are congruent. Well, we already used these pair of angles, 2 and 7. That's what we're trying to get to. And so we only have 2 choices here. angles 3 and 6, or angles 2 and 6? Well, if we look at 3 and 6, those are not corresponding angles. Remember, 3 and 6 are alternate interior angles, so it wouldn't make sense to put them here and say they're corresponding. So the correct answer for this statement is angles 2 and 6 being congruent using the corresponding angles theorem. They are corresponding angles, and since your lines are parallel, they have to be congruent to each other. Our third block has angles 6 and 7 being congruent. So remember, we have a name for 6 and 7. They are the non-adjacent angles formed by intersecting lines. They are called vertical angles. We know vertical angles are congruent because of the vertical angles theorem. It just states that vertical angles are congruent. That's all that the vertical angles theorem is. So now we're ready to get to our final statement, which is 2 is congruent to 7. And the reason we know that is because of these two statements here. We have 2 congruent to 6, 6 congruent to 7. So since 2 and 7 are both congruent to 6, we know we can say they're congruent to each other. And again, that's the transitive property that simply states if A equals B and B equals C, then A equals C. 2 is congruent to 6, 6 congruent to 7, so 2 is congruent to 7. So we just proved what's called the alternate exterior theorem, which states if you have parallel lines, then the alternate exterior angles are congruent. The converse we will also prove eventually, and that states that if you have two lines cut by a transversal which make the alternate exterior angles congruent, then you know as a result that the lines have to be parallel to each other. All right, so our next proof, we're going to be looking at the consecutive interior angles. So remember, consecutive just means same side, whereas alternate meant opposite sides of the transversal. Now we're looking at angles on the same side of the transversal. Interior still means inside the parallel lines. So we have two pair of consecutive interior. 4 and 6 are consecutive interior, and 3 and 5 are also consecutive interior. We're going to prove that 6 and 4 have the supplementary relationship. So again, remember, these are not congruent. 4 is obviously an obtuse angle, 6 is obviously an acute angle, so it wouldn't make sense to say these are congruent. They are definitely not congruent. They are, however, supplementary, which means they add to be 180 degrees. So let's look at filling in this proof. We know the first statement is easy. It's just what we are given, because it tells me my reason here is given. So J being parallel to K is the very first statement. They took away another one of our easy parts, the fact that we know we want to end up with angles 6 and 4 being supplementary. So let's look at our second step. It says angles 2 and 6 are congruent. Well, remember, we've been talking about this since the beginning of the lesson. 2 and 6 have a special name. They are called corresponding angles. We know that the corresponding angle theorem says that corresponding angles that are formed by what type of lines? Parallel lines have what relationship? They are congruent. So we're going to move over parallel lines are congruent. So this states the corresponding angle theorem. Corresponding angles formed by parallel lines are congruent. Now, there's a subtle difference between steps 2 and 3. One says that the angles are congruent, and then we say their measures are equal. Well, all that means is that we understand what congruence means. Congruence means the measures are equal. So this is just the definition of congruent angles as the reason here. If the angles are congruent, that means by definition their measures are equal. Now step 4 was given to us. It says angles 2 and 4 are supplementary. We can see that 2 and 4 are adjacent angles that make a line together. We know they're called a linear pair, and we remember the linear pair theorem tells me that they are supplementary. And then in step 5, if I know they're supplementary, I know their measures have to add to be 180 degrees because that's what supplementary means. So that's simply the definition of supplementary angles. Now I can do some substitution. Since I know that angles 2 and 6 are congruent, then I can replace angle 2 in step 5 with angle 6 and write that angles 6 and 4 add to be 180. And then using the definition of supplementary again, since they add to be 180, that means that they are supplementary. So that proves the consecutive interior angles theorem.